Good morning, students. Today we will discuss the topic characteristics, envelope, and edge of regression for a family of surfaces. So, firstly, let us define what is family of surfaces. An equation of the form function of x, y, z, and a is equal to 0. Here, this a is parameter and can take real values. This kind of equation is called the family of surfaces. Here we have only one parameter, so this equation represents one parameter family of the surfaces. By giving different value to this parameter a, we get different members of this family of the surfaces. Similarly, we can define 2 parameter family, 3 parameters family, and so on. Next is the definition characteristics of family of surfaces. Let us take one parameter family of surfaces which is given by function of x, y, z, and a is equal to 0. Now the characteristics of this family of surfaces is the curve of intersection of two consecutive members of the family. And if we take two consecutive members of the family and take their intersection, then the curve of that intersection, that is the characteristic of the family of the surfaces, and the equation of the characteristic is given by f of a is equal to 0 and curl f by curl a is equal to 0. These are the equations of characteristic of family of surfaces. Now, next we define the envelope of family of surfaces. Let us take one parameter family of surface given by function of x, y, z, and a is equal to 0. Then envelope is the locus of all these characteristics. The equation of envelope is obtained by eliminating a from these two equations. F is equal to 0 and curl f by curl a is equal to 0. So by elimination of a from these two equations, we get the envelope of the family of surfaces. Now let us define what is edge of regression. The edge of regression for a given family of surfaces is the locus of points of intersection of two consecutive characteristics of the family of the surfaces. It means if we take two consecutive characteristics of this kind, f a is equal to 0 and curl f by curl a is equal to 0, and next another member of this kind, then we find the points of their intersection and the locus of those points of intersection. That gives us the edge of regression for the family of surfaces. Now to find the equation of edge of regression, we eliminate a between the equations. F is equal to 0, curl f by curl a is equal to 0, curl 2f by curl a2 is equal to 0. So from these three equations, we eliminate the parameter a to get the equation of edge of regression. Now let us discuss two important theorems based on the envelope and edge of regression. So the first theorem is, show that the envelope of the family of surfaces touches each member of the family at all the points of characteristics. Means जो family of surfaces का envelope होता है वो family के सभी members को characteristic के सभी points पे touch करता है. तो ये prove करना है. तो in order to prove this, let us take a family of surfaces, one parameter family given by function of x, y, z, and a is equal to 0. Here a is a parameter. Now by definition, we know that the equation of envelope is obtained by eliminating a from the equations f is equal to 0 and curl f by curl a is equal to 0. Now this equation of envelope can again be written in another form. Now if we find the value of a from this equation, and then we can see that a will not be a constant, that will be a function of x, y, and z. So the equation 1 can be rewritten in the form function of x, y, z, a is equal to 0. Now here a is the function of x, y, and z which is given by this equation. Now let us find the direction ratios of normal to the envelope. Direction ratios of normal are the direction ratios of gradient to the envelope. So let us find the components of gradient from here. Now to find the components of gradient, the first component will be given by partially differentiating this expression with respect to x. Second component of gradient will be given by partially differentiating this with respect to y. And the third component of gradient will be given by partially differentiating this. So let us differentiate this one by one. Now from here, differentiating with respect to x. So curl f by curl x, because a is not constant, that is also a function of x, y, z. So a will also be differentiated with respect to x. So from here, the partial derivative with respect to x will be curl f by curl x plus curl f by curl a into curl a by curl x. Second partial derivative with respect to y is curl f by curl y plus curl f by curl a into curl a by curl y. And the third partial derivative, the derivative with respect to z, that is curl f by curl z plus curl f by curl a into curl a by curl z. So these are the components of the gradient of f obtained from the equation 2. Now thus the normal to the envelope is parallel to the vector this, because from the equation third we have curl f by curl a is equal to 0. So if we substitute the value curl f by curl a is equal to 0 in these direction ratios of the normal to the envelope, these are reduced to curl f by curl x, curl f by curl y and curl f by curl z. But what are these? These are the components of the gradient to the given surface. It means this represents a vector to which normal to the surface is also parallel. Thus, at all the points of the characteristics, the normal to the surface and the normal to the envelope, they are same. And therefore, we can say that the envelope of family of surfaces touches each member of the family at all points of the characteristic. Next theorem is each characteristic touches the edge of regression. प्रूव करना है कि सभी कैरेक्टरिस्टिक जो है एज ऑफ रिग्रेशन को टच करती हैं. तो लेट अस टेक वन पैरामीटर फैमिली ऑफ surfaces given by function of x, y, z and a is equal to 0. Here a is parameter. Let us find the edge of regression. Now as we know, the edge of regression is given by eliminating a from the three equations. F is equal to 0, curl f by curl a is equal to 0 and curl 2 by curl a2 of f is equal to 0. Now if we find the value of a in terms of x, y, z from this equation and substitute above, then edge of regression can be written in another form. We can say that edge of regression is given by f is equal to 0 and curl f by curl a is equal to 0, where a is not a constant now. A is a function of x, y and z, which is obtained from curl 2f by curl a2 is equal to 0. Now the tangents at the point x, y, z to the edge of regression is the line of intersection of tangent planes of the surfaces. It means the tangents at this point of edge of regression, they are perpendicular to the normal to these two surfaces. Now what are normals of these two surfaces? Normal to any surface is given by its gradient. So we have to find the gradient to this surface and the gradient to this surface. So let us find the gradient. Now gradient to this surface is given by curl f by curl x, curl f by curl y, curl f by curl y. Let us do the partial derivatives with respect to x, y and z. So from here the derivative with respect to x is given by curl f by curl x plus curl f by curl a into curl a by curl x. Now the derivative with respect to y, curl f by curl y plus curl f by curl a into curl a by curl y. Third partial derivative with respect to z, curl f by curl z plus curl f by curl a into curl a by curl z. Now the components of gradient for this surface are again given by differentiating them partially with respect to x, y and z. So the partial derivative with respect to x is curl to f by curl x curl a plus curl to f by curl a2 into curl a by curl x. This is the partial derivative with respect to x of this expression. Now again partial derivative of this with respect to y, and then partial derivative of this with respect to z. Now by definition, at the edge of regression, we have curl f by curl a is 0 and curl to f by curl a2 is also 0. So substituting these two values here, we get the vectors curl f by curl x, curl f by curl y, curl f by curl z. And the second vector becomes curl to f by curl x curl a, curl to f by curl y curl a, curl to f by curl z curl a. So above two vectors are reduced in these forms. But what are these? These two vectors are perpendicular to the tangent planes at the point x, y, z to the given surfaces. F is equal to 0 and curl f by curl a is equal to 0. It means we can say that tangent to edge of regression are parallel to the tangents to the characteristics. Hence, we have proved this theorem.